This video lesson is a lesson in absolute value equations and inequalities. When we solve absolute value equations and inequalities, our first step is to isolate the absolute value expression, and then we will solve a pair of equations or inequalities. Our first example is the absolute value of 3x plus 1. So our first step is to isolate the absolute value expression. So we'll undo the addition of 1 by subtracting 1 from both sides of the equal sign. And we end up with the absolute value of 3x is equal to 27. At this point, we remember that absolute value is a distance away from 0. And so we're going to set up our two equations, our pair of equations that we referenced earlier. And that is 1 is going to be moving to the right of 0. And so we have our positive 27. And our second equation is moving to the left of 0. So we have 3x is equal to a negative 27. And so from there, we just go ahead and solve each of those equations. We will undo our multiplication by dividing by 3. And we get x is equal to 9. And then in our other instance, we'll divide by 3, and we get x is equal to negative 9. So if we graph the solution, we would have an answer at 9 and at negative 9. In our second example, we have the absolute value expression. The entire expression is already isolated within the absolute value sign. So we will go ahead and right away set up our two equations, and we have 3x plus 1 is equal to 8, and our second equation would be 3x plus 1 is equal to negative 8. If we go ahead and do our two-step, we subtract 1 from both sides here, and we end up with 3x is equal to negative, or to 7. And if we divide by 3, we get x is equal to 7/3. The other side of our equation, or the other side of 0 rather, we'll subtract 1, and we get now 3x is equal to a negative 9. Dividing by 3, we end up with x is equal to negative 3. So our two solutions on our number line would be negative 3 and a positive 7/3. Remember, as in all of our work, we can always go back and double check that our solutions are correct. If we plug in 7/3 into our original equation, 3 times 7/3 plus 1, that is 7 plus 1, or the absolute value of 8 is certainly 8, so that checks. And then negative 3, if we would go ahead and check that in our original equation, we get 3 times a negative 3 plus 1. That's a negative 9 plus 1 is a negative 8. Well, the absolute value of negative 8 is 8, so that also checks. Now, because we're dealing with absolute value, remember we do have a possibility of no solutions. Because it is a distance, you cannot have an absolute value that's equal to a negative. You don't have negative distances. So this example is an example of what a no solution would look like. Here I'm going to try to start isolating the absolute value sign, or absolute value expression. So I'll first subtract this 16 from both sides of the equal sign. And I get 5 times the absolute value of 3x minus 1 is equal to a negative 5. Let's say I don't recognize this yet as being a no solution. So I'm going to go ahead and continue. I'll divide through by this 5 to make sure I'm isolating the entire absolute value expression. And I get the absolute value of 3x minus 1 is equal to a negative 1. At this point, I've isolated the absolute value expression, and I see that it's set equal to a negative. That cannot be, so this is a no solution. Now let's take a look at a couple absolute value inequalities. We're going to do the same process that we did with the equations. We're going to set up a pair of inequalities. So in our first example, we have the absolute value of 8x is greater than or equal to 24. So we'll set up our two equations. 8x is greater than or equal to 24, and then our other one is 8x is less than or equal to negative 24. Notice that we had to switch the sign because in essence we're dividing by a negative 1 to get that negative 24. So now we'll go ahead and solve each one of those, and we divide through by 8, and we get x is greater than or equal to 3. And on this equation, we'll divide through by the 8, and we get x is less than or equal to negative 3. So on our number line, we see that we have our negative 3 and our positive 3. We're greater than or equal to positive 3. So that's going to be shaded to the right of positive 3. And we have less than or equal to negative 3. So that's shaded to the left. So this becomes an OR. Let's take a look at those same numbers, but now we have a different inequality symbol in between. Now we have a less than. So here we're going to set up the same two situations. We're going to have 8x is less than the positive 24, and now we'll say 8x is greater than negative 24. If we divide through by 8, we get x is less than 3, and in this instance we divide by 8, and we get x is greater than negative 3. If we go ahead and we graph this on the number line, we see that if we look at x is less than 3, we have an open circle here. Let's use a different color. We have an open circle, and we'll be shading to the left. If we Now look at the negative 3, open circle, and we shade to the right because it's greater. So our solution is the intersection. We're going to look at where the black and the blue are intersecting. So this area on the number line is our solution. That means it's an and because it's sandwiched in between. So these two examples of inequalities show us that greater than or a greater than or equal to will result in an or compound inequality, and the less than or equal to results in an and compound inequality.